All of you are doing great. In this video, we'll be doing question number 13, 14, 15, and 16 from exercise 2.4, which are actually the last four questions of this exercise. Now, moving on towards the question number 13, which says if x plus y plus z is equal to 0, show that x cube plus y cube plus z cube is equal to 3xyz. So this is the question. Now, since we know this is an identity that x cube plus y cube plus z cube minus 3xyz is equal to x plus y and then until minus zx. So this whole term is equivalent to this term. That's how we can write it. Now, if we look at the question, then we can say according to the question, we have been given x plus y plus z is equal to 0. So the value of x plus y and plus z is equal to 0. This one is given. Now what we'll do is we'll plug this value in this term. Now we'll write it over here, x cube plus y cube plus z cube. We won't be doing any major changes. We just have to follow this identity, plug the values, and then hopefully we'll be able to find our answer. So x plus y, we have been given this. What it is equal to? It is equal to 0 as per the question from here. So x plus y plus z, sorry, here there's one more z over here. X plus y plus z is equal to 0. So now we'll write 0 in place of this entire term x plus y plus z. And then remaining term, which is this one, we'll write it as it is down here. So this will be x square plus y square plus z square and then minus xy minus yz and then minus zx until n. So you know guys, if anything is multiplied by 0, what it becomes? It becomes the entire thing becomes equal to what? 0 itself. So since this whole term has become 0, what we can do is we can write it right like this over here. X cube plus y cube plus z cube and then minus 3xyz is equal to 0. We can rewrite this thing as x cube plus y cube plus z cube, and what will happen with this 3xyz? We'll move it from left to right, and then when anything goes from left to right, what happens? The sign changes from minus to plus and then plus to minus. So in this case, the sign will change from minus to plus, and this thing will come on the right hand side, which will be 3xy and then z. So this is our entire term. And now if we compare it to the question, what is asked, that's what we have to show. So our answer is right here in front of us, and that's it in this question. Now we'll move towards next question. What we can do is we can just put it in the box so that the answer can be observed by the examiner. Now we'll move towards question number 14, which says without actually calculating the cubes, find the value of each of the following. So we do not have to calculate these values individually. Instead, we have to use some sort of identity with which we can find the values of these directly. So we know we just use the identity on top, just with question number 13, which says x cube plus y cube plus z cube is equal to minus 3xyz is equal to 0. But when it is, and then if we know if x plus y plus z is equal to 0, if these three values are equal to 0, then x cube plus I'll just write it here for your convenience, z cube is equal to 3xyz. So if we need to find the cube of these three, so instead of finding it individually, what we can do is we'll just do it like this, 3xyz. But it is only possible when this condition is satisfied, x plus y plus z is equal to 0. So now we'll check. So if we write part 1 of this is minus 12 and it has got cube on it, and then we have plus 7 and then it has also got cube on it, and then we have got 5 and it has got cube on it. So if we consider minus 12 to be A, 7 to be B, and then 5 to be C, and then if we do the addition A plus B plus C, you'll find that minus 12 and then plus 7 and then we have plus 5 again. So 7 and 5, this becomes 12 plus and then minus 12. So this gets nullified. Minus 12 plus 12 equals to 0. So our condition of A plus B plus C, which is just on top over here, is being satisfied. This entire condition is being satisfied. What we can rewrite this entire cube as 3xyz or 3abc, which in this case we have considered as like this. A is this, B is this, and C is this. So we just have to plug the values now in this, and then we'll be able to find our Q, which will be 3 into A's value. What is the value of A? It is minus 12, right? And then what is the value of B? It is 7. And then what is the value of C? Tell me. It is 5. And then 12 threes are 36, and then 7 fives are 35. And then this is minus 36 into 35. This is our answer. We can rewrite it by multiplying. I'll leave it until here for you so that you can solve it later on. And then we'll move towards part number 2, which is 28 cube, 28 cube, and then plus, and then minus 15 cube, and then plus minus 13 cube, and then we'll just put a separation line over here so that it looks a bit neat, and we'll then change the color to black. And then using the same formula we can do this thing as well. We have to check for A plus B plus C first. If this is equal to 0, then we can rewrite this entire cube as of all the numbers as 3xyz. So now we'll consider A is equal to 28, and then B is equal to minus 15, and then C is equal to minus 13. And then if we try to add all of these, 28 minus 15 and then minus 13, it comes out to be 28 minus 28, which actually becomes 0 in this case. And our condition is satisfied for A plus B plus C is equal to 0, and then we can rewrite the cube of this thing as 3ABC. We'll plug the values of 3. A's value is 28, value of B is minus 15, and then value of C is minus 13, and that's our answer. That's our answer. You can just multiply it and write the answers for it. Now we'll move on towards question number 15 of this exercise, which is basically over here. It says give possible expressions for the length and breadth of each of the following rectangles in which their areas are given. So if we consider a rectangle over here like this, what you can see is if we need to find the area of this rectangle, the formula is for area length into breadth. So we have got two terms. After multiplying these two terms, we get something over here, x, y, z, whatever it is. So if we consider this thing, the first part to be the area of this rectangle, 25a square minus 35a, and then plus 12, then what we can see is we have a quadratic equation, and then we solved quadratic equation in our other chapter as well in polynomial. Basically it was this in the previous exercises. So we just need to factorize this entire thing so that we can get the value. So we'll do the middle term splitting. So before we do middle term splitting, we have to make sure that the middle term multiplied, when it is multiplied, it should be equivalent to first and last numbers multiplication. So basically 25 into 12, it comes out to be 12 to the 24, 12 5 is 60, so it comes out to be 300. So we have to split this 35 in such a way that when we multiply this, we get 300. So we can rewrite this whole thing as 25a square, then minus 20a, and then minus 15a, and then plus 12. So if we multiply 20 with 15, we get another again 300. So that means our splitting is right. So what we'll do is we'll just take common 5 from here, 5 and then a also, and then we'll have 5 and a here, and then we'll have minus sign as it is, and then we'll have 4 over here. And then from here, what we can take common is, we can take common as 3 minus, and then we'll have same thing in here, 5a, and then minus 4. So our two terms are after middle term splitting is 5a minus 3 and 5a minus 4. So we'll have this as our two terms. So we can consider any of those as L, or this one as breadth, or this one as L, or this one as breadth. So this is our answer for this question, 5a minus 3 and 5a minus 4. So this is the length and breadth of our rectangle that has been given to us. Now we move on to the second part of this, which is area is equal to 35y square plus 13y and then minus ka 12. So we'll just write it over here, 35y square plus 13y and minus 12. Now we'll change the pen to get a better understanding of this. So now again we have to do the middle term splitting only in this one as well. So we can rewrite this whole thing as the factors 35y square, and then we can rewrite it as 28 basically wait, plus 28y, and then minus 15y, and then minus 12. So if we multiply 35 with 12 we get 420, and then if we multiply 28 with 15 we get 420. So our middle term splitting is right, and then if we subtract 28 from 28 and then we subtract 15 from it, we get 13 itself. So our middle term splitting is perfect. All we have to do is just take the common. So we'll take 7y out here, 5y from this, because 7 5s are 35, and then y into y is equal to y square. It will recreate this term again, and then we have to write plus 4 to get this term 28y. I hope all of you remember the middle term splitting that we did in previous exercise, and then plus y 5y plus 4, and what we get in the end is as factors is 5y plus 4 and 7y minus 3. So these are the two terms that we got, and we can consider any of those as a length, and then any of those as breadth. It's up to you. You can interchange these L and B. So now we are done with question number 15 here, and now we move on towards our last question, which is basically question number 16. And here it says, what are the possible expressions for the dimensions of cuboids whose volumes are given below? So you guys know that the volume of a cuboid is given by length into breadth into height. So if I try to make a cuboid, it will look something like this. I'm not very good at drawing, so please bear with me. So this will be, you can consider this thing as height, this thing as length, and this thing as breadth. So the volume is given as, V is given as 3x square minus 12x. So in this, there's no rocket science. We don't really have to do much in this question. What we can do is, we see that 3x square is there, then there is 12x. What we can take common from this is 3x we can put out as common, and then we can put x in there. 3x into x is equal to 3x square, which recreates this term. And then from here what we get is, tell me, it's 4. We get 4 from here. So it is 3x into x minus 4. This term when multiplied, or this whole term when you multiply with each of the number in there, with each of the term in there, if you multiply 3x, you will get this whole thing again back. So if you see this can be rewritten as 3 into x and then into x minus 4. So we have got three terms over here. It could be considered as length, this one as breadth, and this one as height. And we have got the answer for our question. Length, breadth, in terms of length, breadth, and height. Now we move on to another last part of this question, which is 12ky square. Here it says, the second part says 12ky square plus 8ky and minus 20k. This is the volume of the cuboid which has been given to us. In this also we don't really have to do much. What we'll do is, we'll just take the common, and then we'll factorize the remaining stuff. So what we can do is, we can write it as 4k here. We can take the 4k out from this, and then what remains in here is 3. 4 3s are 12, right? And then k is out here. Then again what remains inside is only y, and then square. And then from here what we can take out is, already 4k we have got from here, so we can write only 2 in there, right? 2 and then y. And then from here what we can write, minus 5, because 4k when multiplied with 5, 4k when multiplied with 5, we get minus 20k as the entire term. So we have got our factors here. Now this one also we can further factorize this one, because it is a quadratic equation, right? This one 3y square, the degree of y is 2 over here. Again what we'll do is, we'll do the middle term splitting. We don't really have to do much. 4k we can write as it is over here. We'll write 4k over here, and then we'll do the middle term splitting and factorize this term, 3y square plus 2y and minus 5. And if you want to factorize this term, what we'll get is, I'll write this entire thing. This is your homework. You have to factorize this whole thing on your own. We'll get in the end 3y plus 5 and y minus 1. It's really simple, and that's what our answer is. So if you rewrite this entire term, you can rewrite it as 4k separately, and then 3y plus 5 this term separately. Sorry about that. and then this term y minus 1 separately you can write over here. So you can consider any of those terms as your length, breadth, and height. I'm considering this one to be length for now, this one to be breadth, and this one to be height, and that's what our answer is. And now we are done with our today's thing. Hope to see you next time. Bye.